this video, we're going to look at union and intersection, and also the conditional probability. So union and intersection, we talked about that a little bit with Venn diagrams. The intersection is where they overlap, so both things are happening. And union is where you take the whole of both sets together, so either or. So you can kind of think of intersection as and union as or. We know that this relationship is true, and again, you can kind of think about this with Venn diagrams. The probability, sorry, motorcycle going by. The probability of A union B, so this little U shape means union. That just means or, probability of A or B happening is equal to the probability of A plus the probability of B minus the overlap. This little upside down U means intersection and basically means and. So if you think about what this formula up here means, it's the so the union would be everything in this one along with everything in that. So everything that's in either two of the circles. So if you think about probability of A is everything here, probability of B is everything here. But what you notice is I counted that overlapping section twice. So I need to subtract it once. So that's why we're subtracting that. It's because when we filled that in and we filled that in, we consider both of those, we're considering that overlap twice. So we need to subtract it out once so that we're only counting it once. All right, so that's where this formula comes from. We're going to take this formula and apply it in an example here. So in a school fundraiser, 50% of people bought chocolate chip cookies and 40% ordered oatmeal raisin. If 80% ordered chocolate chip or oatmeal raisin, how many ordered both? All right, keyword here is or. So we're going to set up this equation, again, probability chocolate chip, or, you know what, I'm not going to have enough room to do that right there. So I'm going to abbreviate a little bit more, but probability of chocolate chip or oatmeal raisin, call it that, equals probability of chocolate chip plus the probability of oatmeal raisin minus the overlap that it's chocolate chip and oatmeal raisin. So just completely following that formula. Probability that it's one or the other equals probability that it's one plus probability that's the other minus the probability that's both. All right, so I'm just going to plug this in and see what we can do. We're going to end up solving algebraically. So we have 50% bought chocolate chip. So that's, I'm going to write these as decimals. Anytime you're doing math with percents, you're going to change it to a decimal. Probability that it's oatmeal raisin is 40%, so 0.4. Minus the number that ordered both. That's the one thing I don't know, so that's what I'm going to be figuring out from this. I'll just write both here. And then here, probability that it's chocolate chip or oatmeal raisin is 80%. Again, that comes from that keyword there, so that's 0.8. And now, if you notice, this is basically just an algebra problem. It's just instead of an x, we have this probability. But I'm going to solve this as algebra. I'm going to simplify this. And so what I'm going to do, I'm going to bring this up here. And this is going to be 0.8 equals 0.5 plus 0.4, it's 0.9, minus the probability that it's both. And then if we just solve this algebraically, we're going to subtract that 0.9, because what we're trying to figure out is this probability here. It's going to give us negative 0.1 equals, that cancels, a negative probability of both. Notice that it does have a minus in front, so I'm bringing down that negative. And that makes sense too, because this is negative, so I'm going to have to divide by 1, and you know that your probability has to be positive. Otherwise, it doesn't make sense. So we're just going to divide both by negative 1 there, and we'll get 0.1 equals the probability that it's both. So that means 10% ordered both, and that's it. So you can just, if you're given a situation like this, you can plug into that probability of a union formula and go from there. And I know there's not a lot in this unit on this. This is kind of the only type of example that you'll see. So we could spend a lot more time on this, but this is basically what you're going to need for your problem sets. All right, so conditional probability. This is where you're looking for probability of one thing happening given that something else already happened. And it is found by this formula. This little line here just means given. So that's, my marker's dying on me here, given. So A given B, probability of A given B, is equal to the probability of A and B, again there's that intersection, divided by the probability of B. So it's the probability that both happened divided by the probability that that second thing happened. All right, so let's look at an example of this, and this is just a formula. If you just stick with that formula, you'll be good. A college club is selling t-shirts and sweatshirts. It's estimated that 56% of members will buy a t-shirt, 34% will buy a sweatshirt, and 15% will buy both. What's the probability that a person buys a t-shirt given, there's that key word, that they bought a sweatshirt? So this is how you know that it's a conditional probability, that word right there, given that. So what we're going to do is we're going to plug into this formula. So probability that our A is going to be whatever it says, the probability of a person buys a t-shirt, so probability that's a t-shirt, given that they bought a sweatshirt. It's the probability that they did both, so it's the probability of A and B, so the probability that they got both, divided by the probability of B, which is in this case the sweatshirt. All right, and then we just find that information from this formula and we will be good. So it's estimated that 56% will buy a t-shirt. That's not part of our formula, so we don't need it. 34% will buy a sweatshirt. We do need that. That's in our denominator, so 0.34. And then the probability that they get both is 15. So both is that 15%, so that's 0.15. So the probability that they buy both is 0.15, probability that's a sweatshirt is 0.34 directly from this. So in this particular question, we did not need the 56%. If it had said probability that it's a sweatshirt given a t-shirt, we would have, because that t-shirt would have been the B value. And then you just simplify this, and this is 0.44. So as a decimal, it's 0.44, or you could leave it, or write it as a percent if you wanted 44% chance that they would buy a t-shirt if they already bought a sweatshirt. Okay, we're given that. So that's it for this one, and we're going to look at permutations and combinations in the next one.